With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, we have been given about the component of the loudspeaker. Now in the loudspeaker, we will be having permanent magnet, then there would be a basket, then voice coils and flexible suspension, rigid speaker. So these are the component which has been shown. This is the magnet, then we are having basket, voice coil, and then we are having a rigid speaker, and then there would be a flexible mug. Now what is the basic principle? So basic principle would be when someone would be speaking, so there would be a setup of motion. Okay, so the flexible this mug could move in the forward and backward direction. Okay, now due to the magnetic field, so there would be a motion in the magnetic field, due to which there would be some signal which would be generated in the electrical waveform, and then which could be converted into the we can say that in the sound wave to so that they are transmitted to the listener. Now here what is given? Now if the voice coil is wound loosely and there is appreciable gap between the two turns, when the current is passed through the coil, then it would try to contract or it would try to expand, or the current has no effect on coil, or coil will get contracted without the current due to the fixed magnet in the loudspeaker. Now first of all, we should know one of the thing. The thing is that, for example, if we are having two this wire having a current in the same direction, let's say the direction of the current is in the upward direction. Okay, this is, let's say, first of the coil, this is the second coil. Now due to first coil, okay, so what is the direction of the magnetic field on the second coil? So it would be in the downward direction. Using the right hand thumb rule, we can get the direction of the magnetic field would be in the downward direction, okay, into the plane of the paper. Now what would be the magnetic force? We know that F would be equals to I L cross B. Okay, L cross B. This is the in the vector form. So just we need to find what is the direction of our F. So this is our B. This would be the direction of our L vector. It would be the direction of the current element. Let's say this is our L vector. Now if we take the cross product from L to B, what would be the direction of the force? Taking the cross product, it would be in this direction. This is the direction of L cross B, or we can say that F. Okay, that means towards the wire 2. Now we consider the magnetic field due to the second wire on the first wire. So if we use our right hand thumb rule, place our the thumb of the right hand into the direction of the second wire, okay, in the current in the second wire, and the curl our finger. So curling will give the direction of the magnetic field on the second wire. So it would be coming out of the plane of paper like this. Okay, this would be our B. Okay, now the current element, this L vector is in the upward direction because the current is going into the upward direction. So this is the direction of the current element. Okay, now again if we take the cross product, L cross B, if we take L cross B, so the force would be towards the B. Now what we figure out from this example is that when the direction of current is same, so there would be an attractive force between the two wire. Now here what is given? So there would be a coil. Let's say this is one of the coil. Let's say this is one of the coil, and let's say this is another coil. Okay, now the coil, so we have just shown the coil to be a circle, so there is appreciable gap between the two. Let's say this is the direction of the current, so the direction of the current in the coil would be same. Let's say this is I and this is I. So what would be the force, nature of the force, whether it would be attractive or repulsive? We can say that the nature of the force would be attractive. So force would be attractive. Now if force is attractive, so whether it would try to contract or expand. So if the force is this attractive, so it would try to contract. So A would be the correct option, B is wrong. Now the current has no effect on the coil. No, current has an contractive effect. Now the coil would get contracted without the current. No, without the current, it cannot get this force. So D is also wrong. So the correct option is only A option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.